So moin, this video is part of the Scientific Python programming lecture at the University of Bremen, and in this session we would like to start with the development of a larger project. So we will not necessarily deepen our Python knowledge, but we would like to start to get known what is the right way to develop a project which goes beyond these few lines which we were just testing in this Jupyter notebook for simple tasks, but really something which is a kind of programming package. And for that we will start with modularization, so basically get the project into independent modules, and in the next session we would have a look at version control, which is also a very important tool if you are developing something large. As always, we are using our Ubuntu workstation or Ubuntu virtual machine in order to to execute the commands. And if you look at that, you can download the slides, of course, from the usual place. As always, I already did that. And in order to be able to follow basically this in the next session, you would need some additional packages. Please install them with the usual commands. This is spider-free git k and kdiff free qt packages. I already did that on that machine, so I won't demonstrate that because we did that already several times. It should be no problem for you to do so. Also, there will be a few cases where we would use leafpad, and it would be very practical if you would configure leafpad to use a so-called monospace font where every letter, every character has exactly the same width, and that you can do by starting leafpad and then going to the font menu, and in the font menu selecting something which has mono in its name, for example the Ubuntu mono font. And then basically the nice thing is that if you have various letters below each other, they are occupying exactly the same width. Doesn't matter which letter you are using, so that doesn't depend. So it's not proportional, but it's monospaced, and it's quite nice when you have to deal with some small text or programming in this leafpad editor. Okay, so this is basically what we want to do. And we will start a programming project for didactical purposes, and this programming project should be a small project which implements a solver for linear systems of equations. The solver we will use the various algorithms, the Gaussian elimination and the LU decomposition, which are quite similar to each other. And the Gaussian elimination, I assume you know already. If not, you can just look it up at Wikipedia how it works. We would like this package to read in the data from some files, calculate the solution of the system of equations, and then write out the solution maybe also into a file. Very important that we would like to have a test framework for our project. So basically right from the beginning we want to make sure that we can execute a kind of test and make sure whether the program delivers the results which we are expecting, and also to make sure that once we have a feature, if we develop the project further, that there should be a way to be able to say, yeah, the feature which we have implemented before is still working. And for that we will set up an automatic test framework. And last but not least, of course, we want to make sure that our project is well documented and also cleanly written, so that basically everybody we could put it in the internet, and basically everybody could follow up what the project does and help us to develop if there are contributors, right? I would like to note before we start with the project that basically we do that only for didactical purposes. If you really have to deal with linear systems of equations, especially if they are large linear systems of equations, then of course you should use NumPy's or SciPy's built-in routines, which are much more efficient than the one which we will write. But I think the algorithm which we will treat is simple enough and easy to follow, so basically we can concentrate on the other aspects of the code development which are very important and new to you. In order to have this project, we will change our editor. So basically we will leave this Jupyter notebook, which in my opinion is a very nice option if you want to interactively have a look at things, explore things in Python, especially if you want to plot things. But if you are in the process of developing larger projects, then this Jupyter notebook is, in my opinion, not that handy, and therefore we will go to an integrated development environment, an IDE, and there are many different choices you can make. Here in this course I will just present spider-free because it's part of the Ubuntu distribution. It is also an open source project, but if you have some other favorite editor or development system, feel free to use that. If you want to start Spider free, that's very easy to do. You just start Spider free here on the computer. If you start it the very first time on your machine, it may ask whether you want to download some new update. I would advise not to do so. We will use the version as it comes with this Ubuntu system. This is not the newest one, but all the features which you want to explore should be available in this program. And if you start it, you see basically that you have here different windows. There is one window where we will enter the program codes. There's another window basically here where we have where we can have either have information or look at the values of variables or have a look at files in the file explorer. So there are many different possibilities. And last but not least, very interesting, here we have an open Python shell, interactive shell, where we can just basically either run all programs or just test or save something. So basically you can just say print hello, and then that would actually work. So basically if there is something you want to try interactively, then you can do immediately in this Python shell, and that's of course also very useful during this the development. The first thing I would suggest you to go through the tutorial. So this is not something I will show you, because that is something you can do yourself. The Spider tutorial is a nice interactive tutorial. It introduces you basically to the most important features of Spider. So I would very much advise to go through that. I will show the very basic things here in this lesson, but it would be good if you would go through a tutorial to get a deeper knowledge on Spider. Good. In order to collect all projects in one place, we will basically create a new directory in our home directory. So basically you see I'm in my home directory, and now I will just create a new directory. I will just call it projects. And basically you see I already created that before, so it exists already, but it's empty. And here we will collect the various projects which we will develop in the semester. If you want to name it something differently, it's up to you, right? I mean, the name doesn't really matter. And basically in order to start a project, we will basically start a project in Spider. We will do that by going to projects and say new project. And basically it should create a new directory, and the project name should be Lin Solver, because this will be a project for a solver of linear systems of equations, and I would like to store it in this projects folder. So basically I'm selecting projects here, and then I'm clicking on open, and then you see basically it would create a directory in /home Aradi projects Lin Solver, and the project name will be Lin Solver. Actually, if you have already an existing directory with a Python project within, you can also open that as a new project as well, so it's also possible. But basically now we are starting with an empty project. We don't have any files yet. And now that we have created it, there is also here a project explorer, basically which shows only the files within the project, and the project at the moment is still empty. Now we want to create new files, so I will just here go to that, click on the right mouse button, and then say new file, and I would like to create two files. First of all, the file solvers.py. This will contain all the algorithms which we code up in order to solve the linear system of equations. So let's open it, and you see basically it creates an empty file. Well, not empty, there is this coding stuff here. This coding line, actually this coding line is not really important. If you wish, you can delete it already. It was important in Python 2, in Python 3 it's not important at all, it's not really needed. So this temp we can close. And here we will code up our solvers. And because I said to you right from the beginning, we want to make sure that whatever we code up can be tested, and we want to make sure that we are not breaking any features, or that if we implemented features, we are implementing them correctly. Therefore, right from the beginning, we will create a second file which will contain the tests for the solvers. So basically, I will just contain a file which is called testsolvers.py, and I will save that as well. And again, here this coding line is included at the beginning, but if you wish, you can delete it. Okay, and then now I want to save it. So I have saved the both files, and you see in this project there are only those 2 files are present. In order to start with some content, I would like to advise you now to download the content of those 2 files from the website of the course. So basically here, if you click on solvers.p or solvers.py, then basically it will direct you to the website. And in theory, basically, it should offer you the possibility to save or open this file. For example, we could open it by leafpad to have a look at the content. And you see this is a very, very short Python program. I will just with Ctrl-A select everything, with Ctrl-C copy it. And now I will just change to the Spider editor, and I will just with Ctrl-V just include it and save it. And we will have a look at the content in a second. Let's do the same also for the testsolvers.py file. So basically you just go to the slides, you just click on the testsolvers.py, then it will download it and then basically offer you open it. We can just open it directly. We can just select it, copy it with Ctrl-C, then basically change here, change to testsolvers, Ctrl-V, just basically enter it right here. There we go. And this is here the other one, and then basically we have a starting content for our project, and we can now close the browser. We don't need it anymore, and also the files here. Alt F4, you can with Alt F4 you can close the editor, so you don't even have to touch the mouse. Okay, so basically we have saved the 2 files, and now basically we want to have a look what we did. And here basically I have the solvers. It's just a file, and this file should contain all the methods which we are using in order to solve the linear systems of equations. And here I created already a subroutine, a program, a function, if you want to express it this way, which is called Gaussian eliminate, and that would contain of course the Gaussian elimination. And we can already think about it, what the Gaussian elimination needs. Of course, we would have to pass an array A, which is the coefficients of the matrix, and a separate array B, which is the right-hand side of the matrix of the linear system of equations. And then basically what we expect that at the end the program returns the solution vector, which we can just call X or whatever we like. So basically this is the framework for the solver, from one of the solvers. And basically this solver we put in a special file called solvers.py, and it's very typical for large projects. If you have multiple different routines, then you are grouping them in different files depending what they are doing. So for example, here we will have the solvers which are dealing with the solving of the equations. We will have another file which will cope with the I/O, with the input-output functions, so that they are nicely well separated, so we always know where to find the different things. And the question is, of course, how can I access this thing, the routine which is in this file? And basically the answer is that in Python, every file is a module. The modules you know already, we already treated them when we were importing third-party modules, like the NumPy module, which provides us with all the capabilities for the arrays. But of course also the users can write modules themselves, and basically no, a module is nothing more just a file. So basically if you have a file solvers.py, then basically that's a module called solvers. And if you look at the testsolvers.py file, which basically imports NumPy and imports solvers, then import solvers means it will import the content of this file. That means this module will have access to this routine, and the notation of course is exactly the same way as with the third-party module. So basically you have the name of the module, or if you renamed the renamed name of the module dot the functionality, and that would be the same of course with the solver. You have the solvers module dot Gaussian eliminate would exactly access the Gaussian eliminate function in this solvers module. Okay, so basically the modularization, the modules are a way in order to help us to partition things into smaller units, or to collect functions into files. You can see here at the beginning, as shown in the slides, you can start all the similar way. You can start functions with a doc string which documents the function. This is exactly the same how you should start modules. That means at the beginning of the file you are supposed to have a string which describes the purpose of the module. Of course, this is just here, nothing else, just the routines which are collected, or the routines collected which have to do with the solution of a linear system of equations. So that's the doc string, right? And otherwise you just write the definition of the functions which you want to have in this module. As we discussed, you can just basically import it as usually as we are known already, and the same rules apply as for all modules. If Python looks up a module first, it looks in a local directory. Therefore, if testsolvers.py is in the same directory as solvers.py, then wherever testsolvers imports solvers, it will be found automatically because the file solvers.py is in the same directory. So that's easy. It can be also more complicated if the module is in a different folder. Then there are various ways how you can achieve that Python file is nevertheless. And here this Python path environment variable plays a very important role. So basically in Bash you can set it by exporting Python path in a certain directory, and then basically when Python looks for a certain module or a module which you try to import, it will also search in that directory, and if in that directory that file, that module name.p file is found, then it will be imported. And finally, if the Python path has been basically investigated by Python, but the module has not been found, then Python will look up the package directories of the Python distribution. And this is exactly, for example, how NumPy is found, because NumPy is within the package distribution, because we install it with the Ubuntu installer. So it's part of our Python distribution, and therefore the NumPy package can be found in the appropriate directory. This testsolvers.p file is something we would like to execute, right? So basically we would like to have the functionality executed, for example, also from a shell. If you look at this test file, it's basically defining test cases. So let's have a quick look at that. But before we do so, I will just change the font in my editor so that you can see it a little bit better. So I will just go to the tools and preferences and change in the general section, change the font 11, let's say, to 13 points. And yes, that looks somewhat better. Actually, this Project Explorer we could just close to have a little bit more space. So basically, if you look at this test file, what does it do in this main routine? If it's executed, we are defining a matrix A, which are the coefficients of the linear systems of equation, a vector B, which is the right hand side, and then basically we are telling them defining a variable which contains the expected solution, which for this case would be the solution shown here. And then we are also calling the Gaussian elimination and storing the results in xGauss. And then there's a routine which says check results, where we are basically comparing the two of them, whether they are the same or not. And basically at the moment this check result is very sparse. It doesn't do anything much. It just prints both of them, and then you can visually check whether they are agreeing or not. Of course, later we would automatize that, because you have to automatize that, but this is already something we can start with. And you see in this text, basically I have also a second matrix, a second system of equation with a different coefficient matrix and a different right hand side, and then also a third one. And basically all of them we are expecting here. The first one, you see the expected is none. That means here, for example, the system of equation which I'm specifying is linearly dependent, so we would assume that either there is some error message, or the Gaussian elimination program somehow signalizes us that basically this cannot be solved. We will see whether we can manage to implement that. At the moment, the implementation, there is no implementation basically, but this is exactly our purpose, to make sure that the Gaussian eliminate routine in this module can basically for all three tests which we defined here delivers the right results, right? So that's and this is a very common pattern, so that before you write the program you already make some thoughts about that, how to test it. And first, very often it's a very good idea to write the tests first, and then you know exactly you have to modify and write your program until all the tests which you were defining are satisfied. Okay. Yeah, how can we execute this this file here? And there are many different ways to do so. One possibility, of course, is to do it to do it from the shell. So basically here, if we are just going to the projects folder, now we have a linsolver subfolder. We are going here, and here are the test solvers.py. And you remember one possibility to let it run is by just calling Python 3 and then appending the name of the Python file which Python 3 should run. And then we are seeing Python 3 test solver. And then you see, of course, we are far from having the complete algorithm, because here we have the expected results and we just get 0. The expected results 0 and the expected result here is none, and we get nevertheless the array 0. So there's still, so roughly in the quick test we can already see that the program doesn't work. We can also a little bit make it easier to execute it. As you remember, we could just set the executable flag, the X flag of the test solvers.py file to for us to be executable. So now if you have a look at this thing here, you see that basically test solvers.py, which is this one, has the executable flag for everybody. Also, it is now shown green instead of blue, so basically indicating that it's an executable file. And the only thing we have to make sure that the first line of it tells the shell how to execute it, and here it does, because it's a call the environmental program and then basically look up Python 3. So basically it would look up the default Python 3 interpreter which is run if you just type Python 3 on the command line prompt, and whatever follows after that would be passed exactly to that interpreter. So basically from that the shell knows that this program must be run via Python 3. And then basically we could just also execute it directly. Of course the result is exactly the same. So that's two ways of executing the program. Maybe one word on this this main routine, and especially this condition. And if you look up here, you see that basically I have put everything into a routine. So basically there is no code outside of functions. Why do we do so? Because it enables us to a much better programming model. And especially there is one interesting thing is, let's assume I would have here some kind of code, let's say just something completely stupid, a line which prints hello. If I'm executing the code as I did before, I just say test.p, okay, nothing really interesting happens. You just have the additional print command result here, as you can see, and then basically you see that it's printed the hello. The interesting things that happens if I'm just in Python, and for one reason, I don't want to execute this script, but I want to import it in order to get access to the subroutines, to the routines in this script, in this module. Then I could just say import and test solver. Okay, test solver is not found because it's called test solvers, and no, it has been found. But it has, of course, imported all the functions. So basically, I could even here call the test solvers dot check results. No, it's check result. You see, this is a function, so this exists. So basically, I have no access to all the functionality in the script as all the functions. However, at the import, this print statement was executed. So basically this is a side effect, and this is not very nice, because you want only to execute this print statement if you are executing this module, this Python module as a script, but not if you are importing it. And in order to achieve that, there is a way in Python to say whether your stuff is imported or run as a script. And this basically you can decide if there's a hidden variable, a special variable of Python, a system variable which is called __ name. And if this __ name is set explicitly to the value __ main __, then it means that it's run as a script. Otherwise, it is false. And basically this line only tells if I'm run as a script, then basically execute the main function, right? and then basically the main function would be executed. And in order to make sure that nothing is executed, if you are importing it, you should not write any code here, but you should put the code always within this if, or even better, you are defining a routine which from this if is called, and you put all the code which you want to execute if it's run as a script basically into that code. And this is exactly how is it done here. And for example, just to come back to the example which we had before, just a second. So basically, just to here, just to come back to the example which we had before, we could have also, for example, test solver execute test solver.main, and then it would exactly do the same as it did before. So then if you import it, you can do it by hand. But the nice thing is, if everything is packaged in a function, and import itself doesn't make any side effects, it just imports the functionality without making anything else, and that's very desirable. Okay, so that's it. Basically, we have learned how to execute it. And one last way how we can execute it is doing it within the Spider editor. So, and this is exactly the convenient on such editors, that you don't have to change to the bash to the shell, but you can do it immediately. And you can do it basically by pressing the F5 button. I just here rearrange it a little bit. The F5 button, or going on run and run. You see this you can achieve with the F5 button. And if you just push the F5 button, it will ask you where to execute it. And here there are different ways how you can do that. You can basically do it in the current console, so basically here, which is already there, or you can even create a dedicated console for that. So basically it will open a new Python session and run it with there. And if you just run it, you see exactly the same happens. So basically it runs it as a normal file, and all the main routine will be executed. And with that, basically, we have all the tools in order to start our project. And the purpose of the project, as we said, would be to implement this Gaussian eliminating routine, so that all the tests are successfully fulfilled. Maybe we will also add additional tests. And however, before we start with the Python part, there's one very, very important thing we have to do, and that's to learn about version control and about the Git version control system. And that will be exactly basically the task of the next video. Thanks a lot.